Solve triangle ABC if A equals 40 degrees, C equals 22.5 degrees, and B equals 12. And then we want to round to the nearest tenth. The first thing you should do is you should draw out this triangle. Okay, we want to determine what type of triangle is so that we know which law to use. Okay. Now I'm just going to draw this. It's not drawn exactly to scale because I don't really know what the final values are. Okay, but we do know that A is 40 degrees. We know that C is 22.5 degrees, and we know that B here, right? B is 12, okay? So what information are we given? We are given two angles and a side in between, okay? So this is what's known as an ASA triangle, okay? Now actually, in an ASA triangle, it doesn't matter which two angles or which side is given, right? So for example, because we know that as long as we're given any two angles, we can always find a third, right? So ASA, we can call it the same as AAS or SAA. It doesn't really matter. As long as you have two angles and any side, okay, that's called an ASA triangle, right? Okay, so in this case, we need to use the law of sines. Okay, so we're going to use the law of sines to solve this triangle. Now, the first thing we should do is just figure out what angle B is, right? We know that the sum of the angles in the triangle is 180. So we'll take the 180 minus 40 minus 22.5, we get 117.5 degrees. Okay. So now let's just set up the law of sines. Okay, so the law of sines says that the sine of A over its opposite side is equal to the sine of B over its opposite side, which is equal to the sine of C over its opposite side. Okay. And we can flip all of these three over as well. So we could do A over sine of A, B over sine of B, C equals sine of C, as long as they're all the same, right? So let's set this up, right? What do we know? Okay, I got the sine of 40 degrees. Of course, we're going to have to use a calculator to get that, right? Over A, right? We actually don't know the length of side A. That's going to equal the sine of 117.5 degrees all over its opposite side. Now notice that this length we do know, right? That's 12. Equals the sine of 22.5 over its opposite side, which we do not know here. Okay. So these are called proportions, right? Okay. And you notice that we always need to know at least one of these ratios. Okay. So a fraction by itself is called a ratio, but when you set it equal to another ratio, that's called a proportion. Okay. So we can solve a proportion as long as 3 of the 4 values are known. So check this out, right? Look at this. Sine of 40 over A equals sine of 117.5 over 12. And notice that, wait a minute, I should know this value. I know this value. I know this value. So I can just use some algebra and solve for the length of side A. Okay, let's do that. Let's cross multiply these. Okay, so A times the sine of 117.5 over equals, I'm sorry, not over. Okay, that should equal 12 times the sine of 40 degrees. And then finally, we'll just divide this out, right? So A should equal 12 times the sine of 40 degrees all over the sine of 117.5. Okay, now in this case, we'll use our calculator just to get this final answer. Okay, of course, make sure your calculator is in degree mode. Okay, and now one more thing, right? Some calculators, you have to input these in very specifically. Okay, so some calculators, you actually hit the degree first and then hit the sine button. And then other calculators, you can just hit sine 40 and enter, right? So make sure you enter this in properly. Like using parentheses also helps, okay? Well, if you do all this, you should get 8.7 as your answer for the length of side A. So then, okay, how are we going to find side C? So same idea, right? We have a proportion. As long as we know 3 different values, we should be able to work backwards and find a fourth. So let's set it up. Sine 117.5 over 12. Right? And that's going to equal the sine of 22.5 over C. And similarly, we'll cross multiply these. So C times the sine of 117.5 equals 12 times the sine of 22.5, and then we'll just divide this out. So C will equal 12 times the sine of 22.5 all over the sine of 117.5. Okay. Similarly, I don't recommend doing sine 22.5, getting that value and then rounding that. Okay, usually we round at the very end. So if you're able to, right, you should do sine of 22.5, enter, then multiply by 12, and then enter, and then divide by sine of 117.5, and then enter, and then you want to round that answer to the nearest tenth. So you should get 5.2 in this case. Now remember, this is an oblique triangle, right? All that means is it's not a right triangle. And the way that I drew it is not exactly correct because this angle B is bigger than 90 degrees, right? So this would be an obtuse triangle. Okay? Now, you always have to remember that, right? Remember, Pythagorean theorem we can only use for right triangles, but this is not a right triangle. Okay, so in this case, we can use the law of sines.